Okay, so convection. When we take a look at convection, convection takes place in under the earth, it takes place in the atmosphere, and it takes place in the ocean. And when we take a look at convection, we talk about convection currents. And to start off, we need to talk about what drives these convection currents. So in the summertime, you may have seen these balloon type things up in the air. Anybody remember what they're called or know what they're called? What's that? You ride in them.
Oh, hot air balloons.
Okay, so why does a hot air balloon go up? Hot air. So things that are hot go up. Okay, so things that are hot go up. Right? So I'm giving some time for some of this to soak in, and I'm seeing some facial expressions like, yeah, right, Mr. Levert. Why does a hot air balloon go up? Hot air balloons go up because they're hot. Because hot things go up. Right? I don't know if any of you have been out in an attic. A lot of times in the attics, in summertime it's hot. Because hot air goes what direction? Up. Why does hot air go up? Because it's less dense. Okay? So when we talk about convection, the thing that we have to understand is that we're talking about density, not temperature. Okay? Because if we take a look at it, if I have my morning coffee, it's hot. Does it go up? Why doesn't my hot coffee go up into the air? Because it's not less dense than the air. So when we start talking about this idea of talking about temperature and movement, it seems kind of not smart. Okay? So we need to be talking about density. So when we're talking about convection currents, at some point in time, that convection current is going to start going up. Now, we don't necessarily know why that particular area is hotter. Okay, we don't know that for sure. But we know for some reason in the mantle, that area is warmer and the magma is warmer. And seeing as it's warmer, it's less dense. And seeing as it's less dense, it goes up. And as it goes up, it's going to hit a spot where it can't go up anymore. And if it can't go up, it's got to go out. Okay? And as it goes out, it's going to cool. And as it cools, it gets more dense. Awesome. And falls or sinks or drops or some term. Okay? And this sets up the convection currents. Now, you have convection currents in your house, whether you believe or think about it or not. Some of you, if you have an older house, you may have a radiator in your house. Anybody still have a boiler with the radiators in it? Okay. If not, you have a heat register on the side. Most of the time, they put heat registers right underneath the windows because the window's the coldest part. So that when that hot air comes out, it's going to go up. It's going to warm the window so your window stays clear. It's going to go up and over and back down. Okay? So inside your house, you have convection currents set up. And a lot of times, opposite of the room, you have a cold air return. Well, it's called a cold air return. It may not return cold air. It may return warm air in the summertime. Okay? Some of you may have a fan in your ceiling, and you may have a forced convection. Okay? So if you have a ceiling fan, you shouldn't have your ceiling fan going now because it's just important to have it going in the wintertime as it is the summertime. How many of you know why you want to run your ceiling fan in the wintertime? Should that make you cooler? In the wintertime, what kind of air do you want? Warm. Where's all the warm air? Up. So there's a little switch on your ceiling fan. So if you turn it off, first of all, turn it off. Don't try switching it while it's going. Shut it off. Switch it so it goes the other way. So in the summertime, you want that air moving down past you. Because as that moving air hits you, it's going to hit your sweat, or if you're a female, perspiration, and that's going to cool you. But in the wintertime, we want the opposite. You want it pulling that air up, opposite. So it goes up, so that warm air gets pushed out towards the edge of your house, or the edge of the room, goes down and back around. So that mixing of the air is going to make your room warmer because it's mixed better, okay? And this happens not just in the mantle. It happens in the atmosphere, and we'll be talking about that, and we won't be talking about ocean currents. Oceans in Fairmont, Minnesota don't really go hand in hand. Even though oceanography would be an awesome class to teach, we don't have the time to do that. Okay? So,